Hey guys, I'm back with a new video. In this video, let's learn about how we can remove a node from the start of the linked list. So removing a node from the start in a linked list. So here we want to remove the node that is sitting at the head of the linked list, and we want to return the data for the removed node. Now the very first step is to check the size of the linked list. So size of the linked list, say 0 for case 1. For case 2, let us say size of linked list as 1, and for case 3, size of the linked list more than 1. Now for the case 1, if the size of the linked list is 0, we cannot perform the removal in that case. So for that we can simply say underflow. Now coming to case 2, which is size equals to 1. Now if the size of the linked list is 1, this means that we have a single node in the linked list like this, and this is the head of the linked list and the tail as well, and here we have size as 1. In order to remove this, we can simply store the data of this node in some variable. So say the data of this node is d. Let us say we have a variable temp. Then in that temp we will put the data of this node, and the next step will be to set head to null and tail to null as well. So which means these two pointers will no longer point to this node. So head will become null and tail will also become null. And then once we have done this step, we can simply set the size to 0. So this is how we can do one size remove for a linked list, where we are having only a single node in our linked list. Now let us take an example where the size of the linked list is more than 1. And here we have to remove the node from the start of the linked list. So let us say our linked list is this. So 1, 2, 3, 4 and 5. So this is the head of our linked list, and this is the tail of the linked list, which is the last node. Now here what we need to do is we just need to remove this node, which is currently the head of our linked list. Now the steps for removal is that we'll take a reference, say ptr, and let it point to head of our linked list, and then we will define yet another reference, and let's name it as node next to head, and let this reference point to the node that is sitting next to the head of our list, which is 2, right? So now we are having these two references. The next step is to shift the head to point to where the node next to head is pointing at. So now we are shifting our head to point to where the node next to head is pointing at. So head will now come here. Now once this is done, the garbage collector will come into picture and will collect this reference by using the mark and sweep algorithm that we make use of in Java. And the data of the node that we just removed can be accessed by saying ptr.data, right? So after one removal from the start of the list, our new list looks something like this, where 2 is the new head of the linked list and 5 is the tail of the linked list. So here only the head will get incremented by 1, the tail will still remain at the last node of the linked list. So now we know how we can remove a node from the start of the linked list. Let us switch over to our editor and code this out. So I'm back in my Visual Studio Code. So right here, let us define the method remove from start, and what this method will do is that it will remove the node that is sitting at the head of the linked list and return the data for the removed node. So int remove from start. Now the very first step is to check the size of the linked list. So if the size of the linked list is 0, we cannot perform the removal in that case. So for that we can just print a message to the terminal saying underflow, and then we can immediately return by returning a value of -1, indicating that the removal is not possible for this case. Next, if the size of the linked list is 1, so else if size is 1, this means we have a single node in the linked list, which is both the head as well as the tail for the linked list. So in order to remove it, let us define a function and let us name it as handle one size removal. So return handle one size removal. Let us go right above and define this function. So right here, let us define the function handle one size removal. Let us make this as private method so that we can only access it from within the class and not from outside it. So private int handle one size removal. And this is the case when we are having only a single node in our linked list. So the very first step is to store the data of the head node of the linked list in some variable, say temp. So int temp head.data. So now we have the data for the only node of our linked list, which is of course both the head and the tail for a linked list that is having a size of 1. So now let us set the head and the tail of the linked list to null. So head and tail to null. Now once our only node gets removed, let us set the size of the linked list to 0. And finally, for this method, let us return the data of the only node that we collected in the temp variable, which we just removed from our linked list. So this is the implementation for handle one size removal. Now let us go with the other case. So else, if the size of the linked list is more than 1, let us add the logic for the case when the size of list is more than 1. So here the very first step is to make a PTR reference and make it point to the head of the linked list. Next, let us define another reference and let us name it as node next to head, and let us set this to the next of the PTR which is sitting at the head, so ptr.next. Now lastly, we just have to shift the head to point to where the node next to head is pointing at, and this will give us the new head of the linked list, and the first node of the linked list will get removed. So head will now point to node next to head, and now since the node that was previously the head of the linked list is removed and now we are having a new head, let us also decrement the size of the list by 1 because now we have removed the first node of the linked list. Now our PTR is still pointing at the previous head of the linked list that we had, so let us return the data of the previous head node that we just removed. So return ptr.data. So this is the entire implementation for remove from start method. So let us try this out. So right here, let us say linked list dot remove from start, and let us call the display method on our linked list. So let us go to our terminal and run the file. So for compiling the code, java c linked list dot java, and let us run it by saying java linked list. And now you can see 1 is no longer in our list because it was the head node of our list and we just removed it from our linked list, right? So this was all I wanted to cover in this video. Let us move forward to the next video where we will discuss how we can remove a node that is present at the end of the linked list. So let's catch up in the next